Assalamu alaikum, dear students. Today's lesson is about number sets. Let's begin with that. So first of all, what is a set? A set is defined as it is a collection of well-defined objects or elements represented by a capital letter, and we write the elements within the curly brackets. So some examples of sets from the real life are set of subjects books of grade 7, let's say. So we represent it by capital S, and we write the elements within the curly brackets. You can see that the subjects are written within the curly brackets: Maths, English, Urdu, Islamia, Social Studies, and Science. In the same way, another set of color pencils, and we have represented it by capital P, and within the curly brackets you can see different colors: red, yellow, blue, green, white, black, and purple. So the elements are separated by commas and they are enclosed within the curly brackets. In the same way, the third example can be set of months of year, and let's represent it by capital M equal to, and within the curly brackets we will write all the names of the months starting from January, February, and so on till December. So this is how our set is represented. Now let's discuss the types of sets. One type of set is empty set, and empty set does not contain any element. So you can see that here in the this row where I marked set A is equal to, and I have written the curly brackets and no element is written inside the bracket. Even we cannot write 0 inside the curly brackets because 0 is considered as an element. So this is an empty set. It is also called a null set. So an empty set is a set which contains no element. Now finite set. A finite set contains a limited number of elements. For example, set of natural numbers less than 5. So this means set A is going to be equal to 1, 2, 3, 4 within the curly brackets. So this is a finite set because it contains limited number of elements which are countable. Infinite set. An infinite set is a set which contains infinite number of elements. That means you cannot count. For example, set of all the whole numbers, you know that it starts from 0, 1, 2 onward till infinity. And in the same way, the set of stars on the sky, you cannot count all the stars on the sky. Now equal set. Two sets are said to be equal sets if they have same elements and there are also equal number of elements in both the sets. Like set A contains 3 elements, 1, 2, and 5, and set B contains once again 3 elements, which are 2, 5, and 1. So if you look at the elements, both the sets contains the same number of elements, and also these are identical elements. So these two sets, set A and set B, are said to be. Now let's discuss the types of number sets. In our syllabus, we are going to discuss about natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. So let's begin with these one by one. First of all, natural set. The set of natural numbers. Normally, natural numbers are represented by capital N, and you can see that it begins from 1, 2, 3, 4 onward till infinity. So a natural number set has elements which starts from 1, 2, and onward. Whereas whole number set starts from 0, and it also contains all the natural numbers. And whole number set is represented by capital W. Then comes integers. Integers are represented by capital Z, and integers contains all the positive numbers and all the negative whole numbers, including 0. So from here you can see that all the natural numbers can also be called whole numbers or integers. In the same way, whole numbers are also called integers. And you can also say that natural number is a subset of whole numbers, and whole numbers and natural, both these sets are a subset of integers because they are a part of integers. Now let's the rational number and the irrational number, but before that we need to understand what are terminating decimals, repeating decimals, and non-repeating decimals. So on this slide you can see 3 columns. In the first column, which is about terminating decimals, I have given an example here, 5 divided by 2. So if we divide 5 by 2, we will get 2.5. This means our decimal terminates here after 1 digit. So the types of fractions where you divide numerator with denominator and your decimal terminates maybe after 1 digit, 2 digits, or even 10 digits, or more than that even. So our decimal is going to be terminated at somewhere. So these types of decimals are called terminating decimals, where your decimal terminates after a few digits. Now let's go for the second column where repeating. I have given an example of repeating decimal. If we divide 8 by 15, so what we will get 0.53333 and so on till infinity. So this means 3 is repeating. This second digit, which is coming after the decimal, is repeating, and for this reason this is called a repeating decimal, because we can observe some pattern here. And other examples can also be if you divide some certain numerator with denominator, and you are going to get, let's say, 1.494949. So the pattern is repeated. So these types of decimals are called repeating decimals because some pattern will repeat there. Now let's have a look at the example of non-repeating decimal in the third column. and I have given you the an example of pi here. We know the value of pi is 22 by 7. So when you divide 22 by 7, you are going to get 3.14159, and it continues till hundred thousands of digits. The mathematicians, they have calculated, and it is a non-terminating and non-repeating decimal. That we cannot observe any pattern here, and the decimal also the decimal does not terminate here. So these types of decimals are called non-repeating decimals. Hope you got this concept. Now we are going to look at the definition of rational irrational numbers and how to differentiate between them, and this concept will help us to understand. Now, by definition, a rational number is can be expressed in the form of p over q, means numerator over denominator form, and where denominator is not equal to 0, because if the denominator becomes 0, then a fraction of the number becomes infinite, which is impossible. So a rational number is represented by capital Q, and you can see the numbers, the rational numbers inside the curly brackets here. All the positive numbers, the negative numbers means all the integers including 0, fractions whose answer is going to be terminating decimals, or repeating decimals are part of rational numbers, or square roots or cube roots whose answer comes as a whole number, all are rational number. So once again, the rational numbers includes all the integers, means positive integers, negative integers, 0 is also all the terminating decimals, all the repeating decimals, square roots or cube roots whose answer comes as a terminating, either as a terminating decimal or as a whole number, are said to be rational number. So rational number is a big set, and it contains all the integers, whole number. Now let's have a look at what is an irrational number. Unlike rational number, an irrational number cannot be expressed as a ratio of two integers. And two main categories are said to be irrational numbers, where we get a non-repeating decimal and non-terminating decimal, like the value of pi, as we have discussed on the previous slide, that the value of pi is, we know, 22 by 7, and when you divide 22 by 7, we get a decimal which is a non-terminating decimal and non-repeating decimal as well. So these types of numbers are called irrational number. In the same way, square root 2. When we try to calculate square root 2, we get a non-terminating and a non-repeating decimal, 1.414 to 1356. So we cannot observe any pattern here. So this is a non-repeating decimal and also non-terminating, as it does not terminate anywhere. So these types of numbers are called irrational numbers. And then lastly comes the set of real numbers. A real number set is a set of all the numbers, means it contains all the rational numbers, irrational numbers, integers, whole numbers, natural numbers. So every number is said to be a real number, whether it is a rational or irrational number. Now you can see here I have represented these sets by a Venn diagram. So you can see inside the set of real numbers, two circles you can see here. On the right side, you can see a pink circle, which is representing irrational numbers, and a few examples are given there, and all these are non-terminating, non-repeating decimals. Whereas on the left side, the blue circle represents rational number set, and inside the rational number, we can see integers, and inside the integers, we can see whole numbers, and inside the whole numbers, we can see natural numbers. So you can say that all the natural numbers is a subset of whole numbers, integers, and rational number. In the same way, whole number is also a subset of integers as well as a subset of rational and real numbers also. Hope you got that. Now let's assess your skills on the differentiation between rational and irrational numbers. So I have given few numbers here on this slide, and you have to classify these into rational or irrational numbers. And you can pause the video here and you can sort out these into rational and irrational numbers. And once you have done, you have to move on to this slide where I have given you the answers. So this way you can assess your skills.